Hello everyone, I am Shubha. Here I am explaining to design and implement a lexical analyzer and parser for the mini ATC language using finite automata and context-free grammar. And this is our index page, and this is aim and objectives to understand the principle of lexical analysis and syntax analysis, to define a simple programming language called mini ATC, to identify valid patterns such as keywords, identifiers, operators, and to translate a regular expression for a total recognition, to design a deterministic finite automata, that is DFA for identifiers and numbers, to define a context-free grammar, that is a CFG for mini ATC, to implement the lexical analyzer and parser using Python, to test the system with various input programs, to validate both correct and incorrect syntax. Next, introduction. A compiler is a software program that converts a source code written in a high-level language into machine code. The first two phases of compilation are lexical analysis and syntax analysis. Analysis is nothing but parsing. First one is lexical analysis. It reads the source code character by character and groups them into meaningful units called totals. Like for example, int x is equals to 10. Int is a keyword, x is identifier, equals is assignment operator, 10 is number, and semicolon is delimiter. Parsing, that is syntax analysis. It checks whether the sequence of totals follows the grammar rules of the language. Valid example is speed is equals to 450. Invalid example, speed is equals to speed 450. Mini ATC language. Mini ATC is a simplified programming language assigned for educational purpose. It includes the variables declaration, assignment statements, arithmetic expressions, print statement. Features: integer data type only, variables, arithmetic operators, print statement, semicolon based statement, termination. Keyword is int and print. Plus, minus, multiplication, division, equals are the operators, and semicolon, open and closed parentheses are the delimiters, and example is int x is equals to 10 plus 20, print x. Lexical analysis and parsing design. Lexical analyzer design. The lexical analyzer performs the following tasks, that is read source code character by character, ignore spaces, tabs, and new lines, recognize tokens, report lexical errors, produce a token list. Parser design. The parser performs the following tasks, that is read tokens from the lexical analyzer, match grammar rules, build the syntactic structure, detect the syntax errors, report whether the program is valid. Design approach is lexical analyzer uses regular expressions and finite automata. Parser uses a recursive descent based on CFG. Totals and rules. Total characterize. Keyword is reserved words. So example in print. Identifier is a variable name. Example x comma total. Number is integer constant, that is 10, 20, etc. Assignment operator, that is equals, plus addition operator, minus is a subtraction operator, multiple is a multiplication operator, divide is a division operator. L parent is a left parenthesis, R parent is a right parenthesis, semicolon is a statement terminator. Lexical rules. Keywords. If a lexema exactly matches it int print, then it classified as a keyword. Identifier rules. First character must be a letter, remaining characters can be letters or digits. Number rules. One or more digit. Operators and delimiters is a single character, tokens are recognized directly. Regular expressions. Regular expressions define token patterns, that is a letter, this is a digit, and this is identifier, and this is number. Int print is a keyword, equals is assignment operator, this is arithmetic operator, and this is parenthesis, semicolon, And next one is DFF for identifiers and numbers. DFF for identifiers rule is an identifier begins with a letter and may contain letters or digits. And this is the state diagram, that is nothing but a test representation. States Q naught is a start state, Q1 is accept state. Accepted strings are H sum total 1 A B C 1 2 3. Transition table, this is our transition table. And the rejected strings are 1x at name are the rejected strings. DFF for numbers rule, a number consists of one or more digits. And this is the state diagram. And this is a transition table. Accepted strings are 0 1 2 3 9 9 9. And 12 a 12 is a rejected strings. Implementation part, this is the code I am used. And the next is a sample input and output, this is a sample input and this is the sample output. Finally it shows the syntax is valid. And next is test traces. Test trace one valid program. Input int x is equals to 5, print x, then syntax is valid is the output. In test test 2 missing semicolon int x, here there is no semicolon, then the syntax error shows in the output. And test test 3 valid arithmetic expression. Input x is equals to 10 plus 20, output syntax is valid. Test 4 print statement, print x, and syntax is valid is the output. Final conclusion, the mini ATC lexical analyzer and parser we designed and implemented using finite automata, contest-free grammar. The lexical analyzer tokens such as a keyword identifier, numbers, symbols, and etc. The parser checks whether the token shows the grammar rules mini ATC language correctly accept valid programs or not. This project uh, helps to find in the basic concept of compiler design and use the automata theory. And this is the reference. Thank you.